All right, so today we're cracking open something really fascinating. It's a document that could be the blueprint for the engineering degree of the future, one designed from the ground up to be completely AI first. And really, this is the million-dollar question, right? Tech is moving at this unbelievable speed. So how do you get students ready not just to use AI, but to think with it, to build with it, in a way that's, well, completely natural? Well, it turns out a university in Ukraine, the Ukrainian State University of Railway Transport to be exact, has put together this incredibly detailed playbook. So let's dive into their master's program in computer engineering and see exactly how they're taking on this challenge. So our story kicks off with the university's Intellectual Information Technologies program. Since 2017, they've been focusing on what's called the Artificial Intelligence of Things, or AIoT. And that's basically this idea of weaving smart, connected AI directly into the physical devices all around us. You see, the problem they're trying to solve is a big one. Traditional engineering programs, they're just struggling to keep up. So the goal here is to have master's students graduate not just knowing about AI, but being totally fluent in using it, both as a tool for their own work and as the very heart of the systems they design. And this quote from the program's guide, man, it just perfectly sums up their entire philosophy. When it comes to the students' final projects, AI isn't just some optional extra, it's the whole point. It's the destination and it's the car that gets you there. So, okay, how does this actually play out for a student? Well, the whole journey is broken down into two major parts. The first is called the pre-diploma practice. It's a 5-week period that is 100% focused on design and modeling. And believe me, this isn't just some, go figure it out kind of deal. The program enforces this really structured design process. And that rigor, it forces students to go way beyond just having a cool idea. They have to prove that it's actually viable and think through every single angle before they even think about building anything. One of the very first tools they have to use is a UML, use case diagram. I love this. Think of it like drawing up the architectural blueprints for a house, but for a piece of tech. It forces them to map out exactly what the system needs to do and who it's for, making sure they have a really clear, user-focused vision right from the start. Okay, so next, students get to play with this really cool AI tool called a fuzzy cognitive map, or FCM. It's all about mapping out cause and effect in situations where things aren't just, black and white. Think about trying to model something like user comfort or traffic flow. It's not a simple on or off. So they use this software called Mental Modeler to map out these fuzzy relationships, which is absolutely essential for designing smart, adaptive tech. All right, so once they've got that solid design, it's time to roll up their sleeves for phase 2, the qualification work. This is pretty much their master's thesis, and it's where all those detailed plans have to become a real working prototype. And this slide really nails the difference, right? Phase 1, that's all about the what and the why. It's the blueprint. Phase 2 is the big pivot to the how, actually building the thing and, making it work. And get this, they aren't just let loose with any old software. There's a mandatory stack. They use MATLAB for the heavy-duty math and modeling, Node-RED to brilliantly connect all the different hardware and software pieces, and tools like Tinkercad to design the physical circuits. This stack makes sure they can handle the whole process, from abstract ideas to actual hardware. And just take a look at the projects they're actually building. I mean, these are not your average homework assignments. We're talking about smart medical homes, security systems that use advanced algorithms, robots that model emotion, and even drones that can make their own calls when they lose connection. This is some seriously ambitious, cutting-edge stuff. But here's where it gets really interesting. Beyond the specific projects, there's this deeper philosophy, a mandate really, that makes this program so different. It's all about how students are forced to engage with AI as a partner in creation. The program is crystal clear on this point. Students have to use AI assistants like ChatGPT or Gemini in their work. But, and this is the key, they have to do it responsibly. They're trained to be critical, to really get the limitations of these models, and to never just blindly copy and paste the output. And this is my favorite part. It's so meta. The university actually practices what it preaches. The author of the very guidelines we're looking at, Dr. Petrenko, used an AI tool to analyze her own document. So what did she do? She fed her entire 64-page document to Google's Notebook LM and just gave it a simple prompt: make a mind map. And at first glance, hey, not bad. The AI correctly picked out the 4 main sections. But this is where the real lesson starts. But then she did exactly what she wants her students to do. She looked at the AI's work with a critical eye. She points out that the structure it made was really imbalanced, that it randomly pulled some details but totally ignored others. This is the lesson, right there. AI is an amazing assistant, but it's not a genius. It needs a skilled human to guide it, to check its work, and to fix its mistakes. And to make sure this all sticks, to really formalize it, every student has to sign a declaration of uniqueness. They have to promise that the work is theirs, and that if they used any material from another author, including an AI, it's been properly cited. It just bakes academic integrity right into the process. So, after all of this super intensive AI-first process, what's the payoff? What kind of engineer walks out the door at the end? Well, the whole program is engineered to build a new kind of professional. Not just someone who knows facts, but someone who can walk into a messy, undefined problem and create structure. They're taught to be adaptable, to not see hardware and software as 2 different worlds, but as one single system, and to build all of it with a real sense of its ethical impact. So in the end, you realize this isn't really just a degree about building AI. It's a degree in thinking with AI. It's about creating a new type of engineer, one who's more creative, more adaptable, and ultimately more powerful because they see AI not just as a technology, but as a real intellectual partner. And that, of course, leaves us with one big final question. We've just looked at a really detailed playbook from one university, but could this AI-first, critically minded approach be the actual blueprint for the future of all technical education? Now that's a fascinating thought. Thanks for joining us for this explainer.